All right, hello Michael and Reese and Josie and Mackenzie and whoever else is watching this video. What?
You said Mackenzie's not in 1X.
Oh, Mackenzie's not in 1X. Sorry, Mackenzie, you're not watching this. We are on number 20. This is the review. We're going to finish the review, so we only have like basically 2 pages left, and these are the short ones, the short questions to go through. And then on Monday we will go fill out a note card and we'll do some whiteboardy stuff. Okay. So number 20. Here we go. We have to figure out what the measure of each is, and then name the theorem. Okay. That justifies or tells us how we know that that's a thing, okay? So angle 7, this guy here, is 5x plus 5, and this one is x minus 5. Now, those are not equal to each other. Like, we can clearly see that, right? But what are they? They equal 180. So if we add them together, equals 180. If I add this together, I have 6x. Oh, hey, the 5 and negative 5 cancel out. 6x equals 180. Divide by 6. 30. X is 30. Okay, but they want us to find the measure of each numbered angle. So if x is 30.
8 is 25.
If we put 30 in and 30 in, you said 8 was 25 because it's just 30 minus 5, so 25 degrees there. And then I could get away with not even plugging it in here. I know that if 8 is 25 degrees, these two have to add up to be 180, right? So like 130, 135, 155, 155. I don't know why I said 135. 155. Blah, blah, blah. Okay. So either way you want to find it, there you go. Those are the 2 numbered angles. Oh, how did we know that?
Common
Do we have a
sense.
theorem?
They're linear.
They're a linear pair. Let's just put linear pair down, because that's the justification for it. They are a linear pair, whatever theorem that is. It might be the supplement theorem, because they are supplementary if they are a linear pair, whatever the one that is, okay? So linear pair, a supplement theorem, what?
2.3.
Theorem 2.3. So any of those I would accept as justification for why that is. Doesn't necessarily have to be a theorem, but anyway. Okay, 21? Ready? Okay, they give me 8, and they give me 7, and they give me 6, and they give me 5, and that's what each one of these, right, is. 5 is 5x, this is that, this is that, this is that. Are any of those equal to each other? It looks like maybe 6 and 5 might be equal to each other.
They all add up to 180.
But we don't know that for sure, but we do know that they all have to 180. They're all like on this straight line. So it's like a linear pair on steroids. We have 4 of them, right? Okay, so if we add them all up together, all right, I'm gonna paraphrase and I'm gonna like not write down all my work. If I add the x's, 5x plus 4x, that's 9x, plus another 10, 19 plus 12 is 31x. Okay, got it. All right, then all I have to do is add the 6 and the negative 12. Minus 6, okay, and that's equal to 180. All right, so I really condensed that and didn't write out my work, but it's faster that way, okay? All right, then let's add the 6 over. So 31 equals 186. And that should be 6, exactly, perfect. Yep, 31x. X equals 6, okay, then we plug back in. Blech. Plug back in. All right, so some of these are easy to plug back into.
25 from 5.
So
Or 30, I mean.
6 right here. 5 is going to be 30 degrees. That's one of my answers. If I plug 6 in here, that's 24 plus 6, so 30 again. Hey, those two are the same. We said that they kind of looked like maybe they were the same. Angle 7 is 60 degrees if we plug a 6 in. And this one, if we plug 6 in, do you know what 12 times 6 is? 72 minus 12. 60 also. So hey, 7 and 8 are the same, right? Does 30 plus 30 plus 60 plus 60 add up to be 180?
Yes.
Yes, it should. Okay. What's the justification for that?
Same one as last time.
Same one as last time. I would say linear pair, except it's linear pairs. I think a pair is always 2, but like pairs, there's a couple, like 4 of them. Or the supplement theorem, they're all supplementary to each other. 2, 3. Either one of those will work. I will take that. Okay?
Are we able to use our green sheet?
Yes. Yes. Yep. Green sheet. Yeah. Whatever Riley just said. Are we able to use our green sheet on the test? Yes, you may. 11 is 11x and 13 is 10x plus 12.
This is all the same. Like they're all adding up.
Yeah, they're all adding up to be 180, right? Okay. So that would be 21x plus 12 equals 180. Minus the 12. What's 180 minus 12? 168.
Or 68, yeah.
168, and that is 8. Perfect. Okay, plug back in. Angle 11 should be 88 degrees. Okay.
Something with the 2 is the last number.
Something with a 2 is the last number. 80 plus 12 is 92. Yeah? Okay, and 92 plus 88 added to 180. Now, what also, we have to do angle 12, which we didn't give anything for, but it's a numbered angle, so we have to label angle 12 as well. Gonna be what? 88 as well?
Yeah.
Okay, so I'm gonna say, so this one has a little bit different stuff. We have the linear pair slash supplementary angle or supplement theorem going on, just like before.
And vertical.
Supplement theorem, but we have to add to that that we did vertical angles. Angles, there we go. So that was how we got 12. Okay, good?
Oh, these next ones.
All right, these next ones are super fast and easy, right? Okay, we know that these two lines are parallel, right? Because they have the little arrows. So these are going to be my transversals. And they're going to pick on not both of them at the same time, but just like one pair of them. We have to figure out if 9 is 80 degrees. I'm going to label him, and 5 is 68 degrees. Okay? Now, it's important to note that the two lines that are parallel are these two, okay? So these intersections are going to be the same, and these intersections are going to be the same. So like 68 degrees will not be up here, right? Okay, because that doesn't follow along that parallel line. So those groupings will have the same measure. Those groupings will have the same measure. All right, so they want to know angle 12. Okay, angle 12 is this guy right here. He is right next to 80.
Right.
So he is going to be 100. Why?
Because they're on
9 and 12 are a linear pair or supplement theorem. Okay, so on 180, I'm going to say linear pair.
Isn't it 100?
It should
Not
be
100, not 180. 100, I can't think this morning. It's too early. Linear pair. 100 or supplement theorem, whatever you want. Okay. 24 is angle 1. Okay, so angle 1 in relationship to the original one, 90 that we were given, or angle 9 that we were given. Those two are
Alternate, or no,
corresponding. So angle 1 should be 80 degrees as well because they're corresponding. So 80 degrees corresponding. Corresponding. Okay. Now we bump down to angle 4, which is this guy right here. Okay, in relationship to the original one that we were given. I know he's a linear pair to angle 1, but in relationship to angle 9, because that's what we were originally given. Does he have a relationship to angle 9? Not really. He doesn't have an angle pair relationship. So what is he though?
112.
No,
100.
He's gonna be 100, right? But how, like, what is our justification for that?
Linear pair. Problem.
Linear pair? Should we just say he's a linear pair with angle 1?
Yeah.
Yeah, sure, we can do that. That's fine. That's kind of a weird one because
We
you can't jump straight from angle 9 to angle 4. So we'll just say linear pair with angle 1. That's fine. Okay. All right, angle 3. We're really staying in this top little loop right here.
Yeah, the last two are on the bottom ones.
Angle 3. Okay, what's angle 3 in relationship to 9?
Alternate.
Interior.
Alternate interior. So angle 3 is
80.
80 because alternate interior. Am I making you dizzy yet?
No.
Okay. 27 is angle 7. Now we're down the bottom. Okay, angle 7 in relationship to angle 5. Those are vertical because 68. 68 and vertical. Okay, and last one is 16 in relationship to 5. Do we have 16 in relationship to 5? We have 16 in relationship to 7 though.
Alternate
That's
interior.
corresponding.
Those are
Consecutive.
consecutive interior. 7 and 16 are consecutive interior, which means that they
112.
are
112.
112. 68 from 180 is 112. Sure. I'll buy it. Yeah, so you can't go straight from angle 5 to angle 16, but you can go from 7 to 16. That'll work. We'll take it. Okay, backside. Okay, I don't want to graph these.
Consecutive interior?
What? Consecutive interior, yeah, that's what it said.
Okay.
Parallel, perpendicular, neither. Okay. to determine that, we look for slope. So parallel lines will have the same
We
slope.
can write this down on a note card.
Yeah, we could. Same slope, perpendicular are going to have the negative reciprocal slope.
We're gonna
Same
be able to
slope,
use these
negative
on the
reciprocal
test,
slope.
right?
What?
We're gonna be able to use this on the test.
What? The review? No.
Yeah. No?
No. The blue sheet though, or blue, is it blue or green?
Green.
Green. Get it in your brain. It's green. It's green sheet. You can use the green sheet and then we'll write down some stuff on the note, on a note card. Okay. Parallel, perpendicular, or neither. So let's look at slopes. N and M go together, and R and S go together. So let's find the slope of NM. Y2 minus Y1, X2 minus X1. So 4 minus 3
1,
over 2 minus 0.
2.
So that is 1 over 2, which is 1/2. Okay? All right, this guy. 4 minus 1.
3.
8 minus 2.
4.
Nope, they are
No.
Nope, they're parallel.
4 minus 1
Remember-
is 3.
remember
8
6.
minus 2 is
6.
6.
Half.
Half. So they
Oh,
are
yes.
parallel. I think you were dividing by 2 and you put 4 instead of
Yeah, I did.
subtracting 2.
You're right,
That's why.
you're right, you're right.
Yep. I followed you. It was fine. I promise you do know how to subtract, but you were dividing. So anyway, parallel. Good? All right, MN. Do you want to try this on your own?
Sure.
Sure. Okay. I'll just do it silently and you check with me. Just be careful because you can make mistakes really easily on these.
Yeah, I hate negatives.
Is negative 1 minus 1 then?
I'll tell you what I do for these problems. If I get a result that's parallel or a result that's perpendicular, I don't really even think twice. But if I get a neither result, I usually go back and check my answer. Does that make sense?
Okay, so
Because the chances of me screwing up and still getting them to be parallel or perpendicular is probably slim to none. But if I get neither, maybe I did screw up. So if I get a neither, I usually go back and check my work to make sure that it wasn't parallel perpendicular instead. But if I actually get parallel perpendicular, I usually just stop and say that's probably what it is, right? Make sense? Yeah? Did you get perpendicular for that one?
Yeah.
You messed up?
Yeah.
Okay. All right. Okay, graph the line that satisfies each condition. We wanted to go through 6, 2.
I did it.
1, 2, 3, 4, 5, 6, 2. And I wanted to have a slope of 3. So up 3 over 1, up 3 over 1, or down 3 left 1, down 3 left 1. And I want it to be this line. But I want to graph the line. We don't need the equation of the line.
No.
Well, on the test, I'm probably going to ask you for the equation of the line. Should we go through and do the equation? Because I'm going to probably ask you that on the test. I don't know why I don't ask you that.
Wait, what did you
We're
get?
gonna have to go off the graph, that's why.
What did you
What?
get for 30?
For 30, perpendicular. This is negative 1/2 and 2.
Oh yeah.
So this one, the graph of him looks like that, but if I'm trying to write an equation, y equals 3x plus b. The only thing they don't give me is the b part. They give me the slope. How do you find the b?
Plug that point in.
Plug 6, 2 in. Or I could look at my graph to figure out where he intersects. He's going to intersect down here somewhere, but I have no idea what that point is at, right? He's some negative number, right? Okay, so let's plug 6 and 2 in. 6 goes here, in for x, and 2 goes here, in for y. So 3 times 6 is 18, and I have 2 plus b. If I subtract the 18 over, b will be?
Negative 16.
B will be negative 16. Okay, we said it was down there a negative, so the entire equation will be y equals 3x minus 16, okay? So, there's that. Okay, good. Okay, perfect. Passes through 8, 5, okay, so 8, 5, 8, 5, something like that. Okay, and I want it to be perpendicular. I'm going to circle or box that word so I know perpendicular, not parallel, with 0, 5, and 3, negative 1. Okay, so I want it to be perpendicular to this line right here. Okay, and so he's going to be something like this. I'm going to find the equation of this line, maybe. And I don't know where my 90-degree angle is. Maybe something like that.
Line that we're perpendicular to is a negative 2 slope, so.
Okay, so he's, Connor says that this guy's slope, the original guy's slope, is down 2 over 1, down 2 over 1, down 2 over 1, right?
Yes.
Okay, so he has a slope of -2. So this guy will need to have a slope of positive 1/2, right? Up 1 over 2, up 1 over 2, up 1 over 2. Okay, it looks like it's crossing here at positive 1, but let's check. So I have y equals, I know my slope has to be 1/2 because it's the perpendicular slope. But if I'm trying to find the b, I can plug in 8, 5 into that, right? You guys see where I'm at? I'm going too fast?
So could you just like go down 1 over 2, down 1?
You could, just to see where it crosses. And I think it is going to cross at 1. Half of 8 is 4. Yeah, and if I subtract the 4 over, I do believe it's going to be at 1. So yeah, given the graph, you could just check, like down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Yep, it is going to intersect at 1. So my equation will be y equals 1/2 x plus 1.
Do we need the red cube
Oh.
for the equation?
I will probably ask you to do it on the test, but
Okay,
technically
cool.
here you don't have to because
I
it
didn't
doesn't
do
say.
it for any of that.
So just make sure that you know how to.
What do you, wait, go
Um,
back. What do you mean it's intersecting at 1?
It's the y-intercept is 1. Right? That's this
we're
guy.
not finding where the lines are intersecting.
Oh.
That's not this lesson.
Not where it intersects the other line. That's not this part.
Got it, that's what
We'll do that later. But where the y-intercept is at 1, right? Okay? Good.
I was confused.
Last one, parallel. This one's parallel, so they have the same slope. Okay, 6, 1 is my dot, and I want it to be parallel to 2, 1 and 7, 4. 1, 2, 3, 4, 5, 6, 7, up 4. Okay, so this is my line. Bup. And I want this green line. Okay, which has to be parallel. Something like this. Okay? All right, what is the slope of the original guy? He's going up 1, 2, 3 over 1, 2, 3, 4, 5. Up 3 over 5? Is that true or no? I think it is.
It is true. Yeah.
Up 3 over 5. So this line has to look like also 3/5 x plus b. Okay, and to find the b, I'm going to plug in this dot, right? This 6, 1, which is going to be really gross as an answer. 6, 1. Oh my heaven's sakes. Oh my heaven's sakes.
3/5 times 6.
3/5 times 6.
6 or 3.6.
3 times 6 is 18 over 5. What did you say? 3.6. So 1 equals 3.6 plus b. If I subtract 3.6, negative 2.6.
Ew.
Yeah, gross.
Can I please have all high school choir members to the gym at this time? All high school choir members, please go to the gym.
Did Michael already go?
I got an email saying they were supposed to go at the beginning of the period. So maybe it was just those few though that they need. I don't know.
Yeah, because he didn't even come in.
Yeah. Well, I saw him in the hallway, so he's like, I'm here. So I said, don't even worry about coming. So there's that. There's the equation of the line. 2.6 is 2 and 3/5 if you want to write it as a fraction instead, so that it kind of matches. But there's that. Good. Okay, couple more. 34. What does this angle and this angle have in relationship to each other?
Alternate interior.
They are equal to each other. They're alternate interior. I'm going to write that down because it says identify the postulate or theorem you used. It is, and technically, we're trying to prove that these lines are parallel. So it is the converse of alternate interior. Because when we're trying to prove that they're parallel, we don't already know that those lines are parallel. It's going to be the converse, okay?
But still,
Converse of alternate
to
interior.
solve it, we should just put them equal to
We
each
just
other,
solve
right?
them by putting them equal to each other,
Okay.
right? So if I set them equal, I'm going to subtract the 8x,
X equals 7.
and I'm going to subtract the 1. So x equals 7, something like that. Find x, okay? X equals 7, there you go. And converse of alternate interior. There you go, that was fast.
That's all we have to
Converse
do.
of alternate.
Converse of alternate interior, yep.
Exterior is the next one.
I think.
Yes, they are. So this is the converse of alternate exterior. Okay, and are those equal?
Yes.
Yeah, 2x, I'll write them down this time. 2x equals 3x minus 20. Okay, how do you solve this one? Typically I would move the 2x over, but
You're gonna have to move the 3.
I do.
Maybe.
No, I moved the 2x.
You did move the
You
2x
can
and he
add
moved the
20
20.
to nothing.
Right.
20 plus 0 is just 20.
Yeah, yeah. So he moved the 2x and the 20 over.
Because then you don't have to
Which
worry
is
about
fine.
negatives in your variable.
Right. I'm just gonna I'll just move the 3x. So negative x equals negative 20. So that means positive x equals positive 20. Yeah. If you move like it, and you can move those in the same steps. So however you want to move it, x equals 20. Converse of alternate exterior. Perfect. Okay. 36. This angle right here and this angle right here. What are those
is it
two?
consecutive or corresponding?
Corresponding.
Yes.
So this is the converse of corresponding.
They're the same still.
But they're still equal to each other. So,
So this one you can even do in your head.
right, equals 70. So if you subtract the 20,
X is 10.
yep, x is 10, right?
Yeah.
So 5x equals 50. Divide by 5, x equals 10. Perfect. Yep.
And the rest of the problems are kind
Very
of a
nice.
joke.
The next of the problems are kind of weird.
Like that one's just you need a piece of paper. and
Yeah. So
final ones
construct
are
a
super
segment that
easy.
represents the distance indicated. So C to AB. So C is like my airplane,
I just wrote
and
it right
AB
down.
is my ground level.
Just go straight out.
You're just going straight down. You're just making a perpendicular, going
I like
straight down.
this.
Yeah, these ones are not bad.
Do you have to put the angle thingy?
I usually do just so that we know that it's a right angle, but you don't necessarily have to, I don't think. All right, now this one, D is my airplane, and I'm going down to AB.
Just write a line through the AB.
So I'm gonna extend my AB line out further. Ugh, I can't draw a straight line. Extend
Doesn't
AB
make it
out,
straight.
something like that, right? And he's gonna be straight down from here. Something like that, I don't know. And you're looking for this line segment, okay? So over here, for this object, the altitude of the line segment that you were drawing down was inside of the shape. Here it's outside of the shape. It doesn't matter, it's fine. Good?
2 more easy ones.
2 more easy ones. 39 is way easier than 40.
They're both easy.
39, they're both easy?
Yes.
Okay.
11 units.
39. What does y equals 8 look like when you graph it?
This way, this slide.
1, 2, 3, 4, 5, 6, 7, 8 on the y-axis and straight across. Boop, 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 boop. -3, 1, 2, 3, straight across. So if I'm trying to do the distance between them, I can just do straight up and down, like making this look like a ladder. And what's the distance of each one of these?
11.
It's going to be 11. Okay, so those I can just count. But this one I can't just count, right? I have to do a little bit more work on this one. Okay, so this one over here. Okay, you just counted?
Yeah.
You did just
Yeah.
count? You go up 1, 2, 3,
But counting doesn't work on this
and it's
one,
up
does
1
it?
over 2, up 1 over. I shouldn't.
No, it doesn't. I think she just counted the distance between 3 and
I think
negative
she
1.
did. Yeah,
Yeah, I did.
Yeah,
you
but they're
can't do
not
that.
straight lines.
Okay.
Why not? It's fine.
So the deal is, so this one's -1, but it has the same slope, right? So I am tempted to just count this distance. But is that the shortest distance between those? Think of this as a ladder, right?
That way.
The ladder needs to go like this. We need to know these distances. So when those lines are at a slant, when the lines are straight, like vertical or horizontal, it makes it really easy. But when the lines are at a slant, you have to work a little bit harder. So like this dot right here is at like 0,3. So let's find what this dot is right here where it intersects, right? So what's the slope of each one of these? 1, right? So if these guys have a slope of 1, what is this line have a slope of?
1. No.
What's the negative reciprocal of 1?
-1.
-1, okay? So if I'm here
And you
at
go
0,
down
3
-1.
and I go down 1 over 1 and down 1 over 1 and down 1 over 1, I'm going to be at
0, 3.
0,
3, 0.
3, 0,
3, 0.
right?
Yep.
3, comma 0. Does that match up the other side? Right? Like here was at -1,
Yeah.
and if I go up 1 over 1, am I going to hit 3, 0? Yeah, so 3, 0 and 0, 3, that's the distance that I'm going between those two. Does that make sense? Okay, and then I'm going to do the distance formula. Okay, so this guy squared plus this guy squared, right? Okay, how far apart are 0 and 3?
3.
3. How far apart is 3 and 0?
3.
3. 3 squared is 9. 3 squared is 9. 9 plus 9 is 18, and the square root of 18 is 4.2.
Yeah.
I remember that from yesterday, because I think we had the square root of 18 before.
I was
How
only-
does a -1b with only a slope of 1 get to will get to 3, 0? Because if you add 1 to -1, you'd be at 1, 0.
Sure.
There's no way for you to get to 3
Oh.
3 0
Oh,
with
yes.
a slope of
What?
1.
What? Back up.
We did some wrong math here.
We did some wrong things. Lies. They're all lies. Yeah, cause 3 0. What the heck?
Yeah, there's no way to get
What
to
the
3
heck?
0.
My drawing is terrible. Let's
Let's go find the graph.
Let's go find a graph. So there we have. Okay,
Yeah,
let's
there
try it. Try again. Try again. Good point, Connor. Good point. Okay, so we are at 3, and we're going up 1 over 1.
Yep.
Something like this, and down 1, left 1, something like this. Okay, and then we're at -1, up 1 over 1, something like this, ish, and something like this ish. Okay, let's
that
fix
makes
it.
a lot more sense.
Okay, so here, if we're starting here, this is at 0, 3, and we go down 1 over 1, down 1 over 1. There we are. This is
Okay.
at blah blah blah.
2-1.
At
2, 1. Ha.
Which
Okay.
fits on line.
Which fits better. But, yeah, because I was kind of questioning that because I'm like, if this distance is 4 right here, and we said that was not the shortest distance, but then we got a distance that was longer. Like, that's not gonna be right. Anyway, so we're doing the distance here from these 2 points. Okay, thank you, Connor. We would have been totally wrong. All right.
2.
So the distance here is 2 because 0 to 2 is 2, and 3 to 1 is also 2. So 4 plus 4 is the square root of 8.
Which is like 2.83. We've done this like 7 times.
2.8.
These
You
numbers are
know,
common.
the square root of 8. 2.8. Perfect.
I was like,
There you
confused
go.
how
That
it
was better, right?
I
Because
just
4.2, you're like, you should have gotten something less than 4, right? Because that's not. Anyway, whatever. There you go. Better.
So basically,
My
I'll
graph is
always
terrible,
graph them
so-
on
Tell
an
your friends
actual
about
graph.
Yep. What?
Call our friends back.
Okay. Is that it? That was all?
Yeah.
Perfect. Look at that. Okay, Monday we'll do some whiteboards and some note cards and stuff and whatever
Bye,
else we
friends.
need to do. Bye, friends.